to factor each expression, and to do that I need to decide on a greatest common factor. So starting with problem number 2, I'm looking at the number 3, and I'm looking at the number 36, and I'm thinking to myself, what is a common factor, the greatest common factor of 3 and 36? So that would most certainly be the number 3. And then once I factor out the greatest common factor, I need to write what I say are called the leftovers. So what's left over? 3 times something gives me 3x squared, so 3 times x. And then 3 times something gives me positive 36. It would be positive 12. And then just to check my work to make sure I've done a good job, I'm just going to distribute. 3 times x gives me 3x. And 3 times positive 12 gives me positive 36. So when I factor this binomial, it factors into 2 factors. One factor is 3. The second factor is x plus 12. When I look at the numbers 42 and 35, I'm thinking of a greatest common factor. I'm thinking of the number 7. And when I write the leftovers, 7 times 6x is 42x, and 7 times negative 5. Greatest common factor for negative 2 and 14 is negative 2. Negative 2 times x is negative 2x, and then negative 2 times negative 7 is positive 14. All right, to determine the x-intercepts, or another word for the x-intercepts are the zeros. To determine those, I'm going to use Desmos today to help me to identify my zeros or my x-intercepts. So we're going to start with problem number 8. And let's pull up Desmos. I have x plus 1, x minus 6. Let's just make sure x plus 1, x minus 6. And I notice that my zeros or my x-intercepts are right here at negative 1, 0, and positive 6, 0. Negative 1, 0, and positive 6, 0. So when I write an x-intercept or a 0, it's written as an ordered pair with parentheses. And as you notice, what we know about x-intercepts, they always have the number 0 for my value of y.
Kathy Orchard, please call 5101. Kathy.
All right, number 8, I have my function y equals 0.25, parentheses x minus 1, parentheses x minus 12. And I notice that my x-intercepts are at positive 1 and positive 12. Number 12 is asking me to write a quadratic function that represents a parabola that opens upward and has x-intercepts at negative 8, 0 and negative 1, 0. So what I do remember is it doesn't have the name of the function, so I'm just going to call this y equals. And if I want my parabola to open upward, my value for a has to be a positive number. So I'm going to select just any positive number. I could select 3, I could select 1/2, I can select any value as long as it's positive, will have my parabola opening upward. And then if my first x-intercept is at -8, then my factored form would be x plus 8, and my other x-intercept for zeros at -1 would be x plus 1. So here's what we want to understand is, why is this the opposite of my x-intercept here? Why is positive 8 the opposite of -8? So what I'm doing is when I'm finding my zeros means that my y value will always be 0. So let's imagine that my y value is going to be the number 0. So if I want this entire equation to be equal to 0, what number would I need to put right here for x and add 8 to get the answer 0? Well, the answer is -8. -8 plus 8 gives me the answer of 0. And by the same token, what number would I need to place right here so that when I add it to 1, I get the answer of -1? And that surely would be -1. -1 plus 1 would give me an answer of 0. Number 14, we need to find the x-intercepts again, and then we'll use a graphing Desmos to do that, and then we need to write this in factored form. So right now, number 14 is in standard form. Standard form, just to remind ourselves, f of x is equal to ax squared plus bx plus c. So that's my standard form, but I need to change that into factored form. So factored form, f of x is equal to a x minus r sub 1, x minus r sub 2. So my x-intercepts are identified by my values of r sub 1, r sub 2, and so let's get to Desmos. So here we have in standard form y equals 2x squared minus 10x minus 48. And I notice that my x-intercepts are at -3, 0, and 8, 0. So what I want to do is I want to take this equation that's in standard form right here, and I want to rewrite that equation so it's in factored form. So what I do know is that let's get this back up here. I know that one of my x-intercepts is at -3, so I know that I'm going to need x plus 3. And my other y-intercept is at +8, so I'm going to need x minus 8. But what I notice is that the graphs are not exactly the same. They're close, and they do have the same x-intercepts, but in my original equation in standard form, I noticed that there is a greatest common factor of 2. And you'll notice the leading coefficient is also 2 from the 2x squared. So I need to place 2 for my value of a in order for the graph in factored form to be the same as the graph in standard form. So my f of x is equal to 2. Already forgot it. X plus 3, x minus 8. And number 14, y equals x squared. And let's see, we want to get rid of this negative sign. X squared plus 8x plus 12 gives me x-intercepts at negative 6, comma 0, and negative 2, comma 0. So therefore, my function in factored form will be f of x equals x plus 6, parentheses, x minus 2. And let's go back. Number 14, I didn't write my zeros down. One of my zeros was negative 3, comma 0, negative 3, comma 0. And my other zero is going to be at 8, comma 0. Determine the x-intercepts for each function and then write it in factored form. Let's take a look at number 18. So what I am not real happy about is this portion right here is not in factored form. In factored form, I need that to be an x plus or an x minus. So let's just take a look to see where my x-intercepts are and then what I can do to rewrite that in factored form. So I'm noticing that I have two zeros. One is at 3, comma 0. And my other is at negative 8, comma 0. So writing this in factored form, if one of my zeros is at 3, comma 0, my first factor is x minus 3. My second factor is x plus 8. Since my other zero is at negative 8, let's try that again. And then notice it's just not matching my original equation. What I'm noticing is that my red function is opening up, whereas the black function, the first one, is opening down. So if I want to get my red function to open down, like the black one, then I need to come back up here and put in a negative value for my A, negative, and I got it to turn upside down so that it's opening down. What's really happening is we are taking this portion, 3 minus x, and we're rewriting it so that it is in factored form. To do that, I factor out a negative 1, which leaves me with x minus 3. Okay, now I'm going to check that just to make sure that we can agree that this is the same. Negative 1 times x is negative x. Negative 1 times negative 3 is positive 3. So I'm taking this portion right here, and I'm just rewriting it. So my function in factored form, x plus 8, and let's move this over. Times x minus 3. And we're going to take this negative 1 and we'll put him right out in the front. And my x-intercepts, negative 8, comma 0, 3, comma 0. I have to do the same with this portion of this function, 2x plus 16. I need to rewrite that by taking out the greatest common factor, just 2, which leaves me with x plus 8, 2x plus 16. So when I rewrite number 20 in function form, I get f of x is equal to, that's my 2, x plus 8. So I've taken care of this portion, and then my x plus 16. Now that's in factored form, I can identify my x-intercepts as being negative 8 comma 0, negative 16 comma 0. Finally, number 22, it's asking me to identify several key characteristics of the function f of x equals x squared plus 2x minus 1. It's a little bit difficult to look at this graph, especially when I'm trying to identify my zeros right here. So to help me this, I'm going to once again put this function into Desmos. So we definitely have a minimum value, and I'm just going to click on some of these key characteristics. So my minimum is at negative 1, comma, negative 2. We also call that the vertex. And it has a y-intercept at 0, comma, negative 1. And I have a 0 in 2 different locations. See if we can read those. Looks like 1 is at negative 2.414, comma 0. The other one is at positive 0.414, comma 0. My domain is all real numbers. My range, let's see, from the lowest to the highest. My lowest value is, back here, my lowest value for my range is negative 2. It doesn't go any further below negative 2. So for my range, I'm going to say x is greater than or equal to negative 2. So it does include negative 2. It is part of the vertex. So from my lowest to my highest, my range is negative 2 greater than. Now my interval of increase. So remember my secret for finding the interval of increase. What I do is put a little mark right here at at negative 1. Negative 1, and here's my negative infinity. Here's positive infinity. So when I want my interval of increase, let's do increase first. It's increasing from this point, beyond this point, into positive infinity. So from, this value right here is negative 1, from negative 1 to positive infinity, my value, my graph, my function is increasing. It's decreasing from negative infinity up to, but not including negative 1. So here's my negative infinity, decreasing up to, but not including negative 1. So here's my